In today's video, here is a nice number theory problem. Here is the following setup. We get 2 to the 3n plus n divided by 2 to the n plus n is a natural number. So we are going to solve this one now. The nice observation we can pick up from this problem. So we get a similar numerator and denominator. So we get here almost we get the same, but here we get the exponent 3, we get the exponent number 1. Okay. So now you may have a nice method here if you want to try to get this problem solved quickly. So if you try to factor out this one and make some kind of relationship between numerator and denominator, and then extract a nice factorization here. So I get solved this problem before with different methods. So if you try to make the reduction here in this one by reducing the equation to mod 256, because if we need to choose n as an even regardless to the other parity, so because everything it looks like the power of 2 here. Okay, so what to do here, I'm going to add 0 by adding n cubed minus n cubed. Why I'm choosing this one? Because this one I will have a common factorization here. Okay, so I get here the following: I get 2 to the 3n plus n minus n cubed plus n cubed all over 2 to the n plus n. So this one is an integer. Okay, now let's make a nice arrangement here by taking this number and this number, because we see the exponents are the same. Okay, so let's do that. I get 2 to the n all to the 3 plus n cubed minus n cubed plus n, all divided by the same denominator, 2 to the n plus n. Now let's factor out this one. So I get here the following: I get 2 to the n plus n factor 2 to the 2n minus n is multiplied by 2 to the n plus n square, all divided by 2 to the n plus n by separating this one by 2 parts. So I get n over 2 to the n plus n. Okay, here is a nice thing: this one and this one is going to be cancelled out because we get the same number here. So now I get this part plus this part. This part is already is an integer. This one also must be integer or natural number. So minus n cubed here. So as we said, this one is also is an integer. Okay, so let's take this minus sign out of these things, becomes plus here. So we get n cubed minus n here, divided by this one. In order to have the fraction is an integer, which means always we get numerator is bigger or equal to the denominator. Okay, so which means I get here this capital A, let's call this one as a capital A, which equals this one minus the other one. Okay, so let's call this one as capital B. So we get capital B here minus n cubed minus n all over 2 to the n plus n. Okay, don't make this minus sign confuse you, because we are comparing just numerator and denominator. Okay, so this is the important thing here. So in order to get this one as an integer, implies n cubed minus n must be superior to 2 to the n plus n, like this. Okay, now let's move over this minus n to the other side. So I get here n cubed superior to n 2 to the n plus 2 times n. Okay, so we get to this inequality now. So now let's make a nice comparison between this term and this term. Okay, now at this point, if n equals 10 if n equals 10, we get here, we get 1024, which equals to 2 to the 10, okay, which is strictly superior than 10 cubed, okay. So this one implies now for all n is superior to 10, implies we get 2 to the n is strictly superior than n cubed, okay. Based on this information that we have here, as you're replacing n with number 10, you get always this one bigger than this one, okay. But we get n cubed is bigger than this one, okay, as we have here, to the n plus 2n, okay. But as we see here, this term is strictly superior than 2 to the n. It's clearly it's a contradiction, okay. It's impossible to get 2 to the n is bigger than 2 to the n, okay, which means this one doesn't hold when we have n is superior to 10. So which means we have no solution above this point. So which means n must be in this set 1 2 3 4 5 6 7 8 9, okay. So as we check in, you will find n equals 1 is a solution, n 2 equals 2 is a solution, n equals 4 is a solution, n equals 6 is a solution, okay. So let's write down that here. You get 1 2 4 6, okay. That's the only solutions that we get, okay. So I have done with this problem. Thank you for watching. We'll see you next video. Bye.